All right, welcome to Earth Science. Let's talk pressure. High and low pressure systems are kind of where the roots of meteorology are going to live. Because the planet heats, and we did do this lab where the idea that land heats faster and cools faster, water heats slower and cools slower. Because there's that difference, you get differences in pressure, which turn into like larger systems, and it makes air move around. And moving air is really all that meteorology is all about. That storm this morning was because air that was different than the air that was here moved into town. Okay. Now this is getting a little bit complicated with this map. When you get one of these in a regions, it's going to be much more simplified. There won't be multiple big systems. There won't be all this other noise, and that's what we're going to draw over here, or what I'm going to draw for you. But we want to think about how things go from high pressure to low pressure, and that's what wind is. Um, and that's always going to be the case in nature. Things go from higher concentration to lower concentration. Higher pressure means that the atmosphere is like compressed there, it's being smushed, it's thicker, and all of those molecules of air are going to want to get to a lower pressure situation. So the general flow of air is going to be away from the highs and towards the lows. Just like it would be in this classroom here, if there was like the whole 10th grade in this room, there'd be a lot of us, it'd be uncomfortable, it'd be high pressure. If we open up all the doors and let, people get more comfortable, they're going to spread out. Nature likes to go from high concentration to lower concentration until there's equilibrium, which was probably a thing from last year, searching for equilibrium. So air does the same thing, long story short. So let's come over here and say that we had a high up here and a low like over here. All right, so what are the winds going to do? Now, here on a spinning planet, the winds don't travel in straight lines. There's this thing called the Coriolis force. It's due to Earth's rotation. Maybe I'll put like what are the really important things. I'll put that down the side here. And I know you don't have this document, but if you want to just make like a bulleted list of what things are important, Coriolis force. Winds due to Earth's rotation, spin. And then we also said winds go from high to low. Okay. So because of this Coriolis force, they also spin at the same time. So as we go away from this high, the Coriolis force essentially makes things bend to the right. This is oversimplified, but this is what Regis diagrams are going to look like. They go away from it and spread to the right, and they go towards the lows. Again, this is oversimplified, but it's okay. So winds go away from high, and then the net spin that happens because of this Coriolis force is clockwise. Towards low and counterclockwise. All of that switches, by the way, in the southern hemisphere. That's where we live, like relative to the equator. That's why that happens. So away from and clockwise, towards and counterclockwise. Those will be questions. Things like that occasionally do show up. Now, what this ignores, though, this is us looking in map view, looking down on the surface of the Earth. It ignores that the atmosphere is thick. There's like a thick atmosphere above the United States there, which, like look into the sky, there's more atmosphere. It's not just flat on our surface. This is a thick thing. So down here, if we say that this line is the surface and we're like looking at it from the side, I always draw like a little mini house, although this house is ridiculously large out of proportion. But it just helps people see like what we're talking about. That we're saying here on the surface, if I look at it like the horizon, if I say that there's a high, the winds go away from that. And yes, they bend to the right, which would mean that they're like coming out of this piece of paper right here. And this one going that way would also bend to the right, which means it's like going into your piece of paper, your computer screen, whatever. Lows, they're going to go towards it. And again, that will be bending right, and towards it. And again, that will be bending right. Well, what about what's going on up here, higher in the atmosphere? If there was no air to replace it, this would be like there'd be no air left in a high pressure system. People would be dying left, right, and in between. In every high pressure system, we know that doesn't happen. Air sinks down from above to replace that hits our surface and spreads out. If you drop a whole bunch of like marbles on the floor, it's just like that. They go down, they hit the ground, and they spread out. Whereas lows, all the air is going towards it, which would crush everybody if the air didn't go anywhere. Well, it does. It rises up off Earth's surface. Okay. All right. Now, I've made mention of this when we did relative humidity and dew points. I normally like berate students for weeks until everybody walking down the hallway, like if you find somebody that already took earth science, will say, I'm going to say, what happens when air rises? And you got to say, expands and cools. There are Regents questions that are often that simple, and they're like freebies if you can remember expands and cools. So we're going to go through the steps here real quick on what happens. So 1, air rises. 2, and I know I'm going like upside down, but it's because as it rises, it expands. Why? Maybe not critical for Regents questions, but interesting, maybe. The higher you go in the atmosphere, the less air you have squishing down on you. Like I lived in the mountains at like 8,000, 9,000 feet. Well, there's less between the top of my head and the top of in the space, the top of the atmosphere there. So there's less pressure squishing on me. As air rises, it has less squishing on it, so it can expand. If we bought potato chips down in the flatlands and then drove them up the mountains to where we lived, the bag would be like all like puffed out and rigid because there's less atmosphere squishing on it. So any parcel of air anywhere that's rising is going to expand. And what that then leads to is that it cools. No, 3. Because of the way that molecules interact with each other, don't panic about that. It expands and cools. Just when they're expanding, the molecules are ramming into each other less, and that is technically what temperature is. Not critical, though. It will cool until... Oh, I don't know what this formatting is in Cami. That's been frustrating. 4, it will hit the dew points. Now, I'm going to spell in here now. I gotta remember how to calculate dew points. We did do that. Of course, I guess if all the Google Classrooms are closed, if you want me to open them back up so you can get to old stuff, or they might be still in your drive. We did a bunch of calculating these things right here. Remember these calculating relative humidities and dew points? There's no way that there's going to be a test without at least one of these problems on there. So review that stuff. And again, if you need help with opening those documents up, let me know. What does that mean, though? When it cools, and it cools and it cools and cools until it hits the dew points. And what that is 5 is dew point is the temperature at which condensation occurs. So condensation really means, I guess if I did 4.5, a mini step, because it's kind of the same thing, that would mean that you're at 100% RH, relative humidity. At the dew point, you're automatically at 100% relative humidity. That's when condensation happens and 6 clouds form. So really anytime that there is rising air, which is a part of being a low pressure system, you're going to get clouds forming. We're going to talk about that in fronts in a few minutes in my next video, but rising air leads to clouds forming. Sinking air is the same exact list, but everything's backwards. So if it sinks, it's under more pressure, so it's not going to expand, it's going to contract. And if it's contracting, it's not going to cool, it's going to heat up. And if it heats up, it's actually not going closer to the dew point, it's going further from the dew point, which means that it's getting drier. So high pressure systems tend to be very dry. High and dry, low and lousy. Okay, if you're generally in a high pressure system, do I still have that weather map up? Out here right now, Dakotas up through Montana and Wyoming, nice sunny days, okay, high and dry. Whereas around this low is where we got precipitation and kind of a mess taking place. Okay, that's a lot. That's a brief overview with a whole lot going on. So let's look at some Regents questions just to see what the expectation is. Surface wind circulation around a high pressure center is going to be which way? which is what that is. So it's going to be away and clockwise. I'm like at number 1. Inner science student observed. There's a chance some of these questions we didn't cover in that because maybe we went in a different order, but let's see. Okay, air masses. Now we did do all those on a different day. We did continental, polar, maritime, tropical. Remember all those things? They were right here. Oh, I can't circle on this. Yes, I can. All of those things. Continental for dry, maritime for wet, like marine biologist. Arctic is frigid, polars are cold, and tropicals are warm. So that gives you all the combinations, really. And then just think about what it's like in certain places. It's cold and dry in Canada, so you get cold, dry air from Canada. Continental, polar, cold and dry. It's warm and wet in the Gulf of Mexico, so you get warm, wet air from the Gulf of Mexico. Maritime, tropical. You can get continental tropical from like Mexico. That doesn't really affect upstate New York, though, at all. And we can get maritime polar coming down off of the North Atlantic. So what this is saying is that first day was warm and humid. The second day the temperature was cooler and drier. So what type of air mass most likely moved into? And it's exactly what's happening. Like this is going to be from yesterday to tomorrow, really. Same exact situation. We're going to be cooler and drier. Continental for dry. If it's maritime means wet, so those are out. And polar for cold. So I'm liking choice 2. What would form a cloud? Rising. Rising forms clouds. And when air rises, it expands and cools. Which air mass is associated with low relative humidity and high air temperature? So I want it dry and warm. To me, that's this, right? Dry, warm, yeah. And again, we don't really get those in upstate New York. Which direction do the surface winds blow? That's just like that one up there. Clockwise and outward. In fact, is it the same exact question? No, just to rearrange it a little bit. All right, so where we have low pressure systems, now what we got to get into, and again, I'm probably going to deal with this on the next one instead, is that these pressure systems will drag weather along with them. This low, acting like a vacuum, sucking air towards it, has pulled cold, dry air down from Canada, which has displaced this. It's also pulling warm, wet air up from the south. And when that cold comes bombing through, that's when it mixed and gave us a storm, like this morning, and I'm not sure if there may be more today. We'll see. So this question may be more valuable for fronts, but oh no, really just for the low, you go towards it and counterclockwise. So I'm looking number 3. All right. And then what we'll have to learn to do is say that this is a cold front coming down from Canada. This isn't part of the question, but it very well could be. In fact, on the regions, I bet you it was. I just didn't put 24 on here. That'd be a cold front with continental polar sweeping down from Canada. This would be a warm front with maritime tropical sweeping up from the Gulf of Mexico. These station models show you wind direction. We got to figure those out too. But this shows us that once these point to where the wind comes from. We always name wind for where it comes from in meteorology, which initially feels weird, but it is the better way to do it. So these northwest winds, it's because you got wind coming out of the northwest, out of central Canada. These south to southeast winds, southwest, are like that because this warm air is coming up from the south. And over here in Old Forge, there's air going that way, being sucked towards that low. So yeah, I know this is all very brief. This is not ideal teaching, but like if as long as you get exposed to a couple of different things, I'm pretty confident that you're going to pass the test as it is. But we might as well try to pick up a couple of these freebies if a few of these topics come up. So I'll do a couple more of these. We'll keep it up. Email if you have any further questions. Hope you're doing well, and we'll see you on Thursday.